Okay, cool. I think the recording has started. So
Okay.
we have our next presenter, Rothpanhaseth. Can you please come forward and present?
Yeah. I already share my screen. Did you see the screen?
Yes, we can see it.
Yeah, okay. So let me start. Hello, my name is Rothpanhaseth, and today I'm presenting my capstone project CollabAgent in the intelligent team orchestration. This research investigates how multi-agent AI, retrieval-augmented generation, and intelligent workflow orchestration can improve collaboration within academic software development team. The core idea is simple. Most project management systems are passive. They extract information, but they do not actively have team coordinate. CollabAgent explore what happens when AI agent become active participant in project management rather than just a tool. I will begin with the problem that motivated this work, then discuss the research foundation behind the solution. After that, I will introduce the CollabAgent architecture, demonstrate how the system works, review and evaluation result, and conclude with future direction. Student software teams face three major challenges. First, project information is fragmented across multiple platforms such as GitHub, email, messaging system, and document repository. Second, most project management tools are passive. They require users to manually update progress and communicate status change. Third, because coordination is likely manual, teams often discover issue too late. Miss dependency, overdue tasks, and communication gap can accumulate until they become project risk. The research gap is particularly important while agentic AI, multi-agent system, and RAG technology have advanced rapidly. There is currently no unified academic platform that combines all three to actively support student software team. That gap motivates the development of the CollabAgent. The motivation comes from the broader industrial transformation. Software engineering is increasingly moving toward human AI collaboration, sometimes described as software engineering 3.0 paradigm. In the industry, AI agents are beginning to assist with planning, coordination, documentation, and development tasks. However, academic project environment remain largely unchanged. To investigate this opportunity, I used a mixed method research approach. Quantitative measure evaluate efficiency and workflow performance, while qualitative data explore user perception, trust, collaboration behavior, and adoption pattern. Combining both perspectives provide stronger evidence that rely on a single method. The, op- the, the opportunity emerged from the convergence of three development. First, agentic systems are become capable of proactive decision support. Second, RAG allows systems to retrieve contextually relevant knowledge rather than rely solely on static information. Third, computer-supported collaborative learning demonstrate that technology can improve teamwork and educational outcome. CollabAgent sit at the intersection of these three areas. The goal is not merely automation. The goal is an intelligent coordination. Three studies were particularly influential. Bala Subramaniam demonstrated how multi-agent rack system can support workflow optimization through autonomous collaboration. Hassan and colleagues introduced agentic software engineering while AI agents act as collaborator rather than tool. Wang and colleagues show that computational approach can improve educational teamwork and learning outcome. Together, this study established the theoretical foundation for CollabAgent. However, they also reveal a gap. Most existing work is conceptual stimulation based or focus on isolated aspect of collaboration. CollabAgent attempt to bridge this idea within the practical academic environment. This is the synthesis metric compare prior research with the proposed solution. Each study contribute an important piece of the puzzle. One focus on workflow intelligence and another on agentic engineering principle, another one on educational collaboration. CollabAgent integrate all three. It contribute in a unified architecture that combine proactive agent coordination, RAG enable knowledge retrieval, and collaborative learning principle. Compared with traditional project management tool, CollabAgent introduces several important capabilities rather than rely on manual status update. Agent continuously monitor project activity instead of keyword search. The platform uses semantic retrieval powered by vector embedding and RAG. Task prioritization become context-aware rather than manual. From an implementation perspective, the system uses a modern web architecture consisting of React, Node.js, PostgreSQL, vector storage, JWT authentication, and event-driven microservice. This architecture supports both scalability and extensibility. This slide illustrates how the system operates from both student and advisor perspective. Imagine a student log in, the system load project data and immediately begin analyzing current project condition. A task recommendation agent identify bottleneck and priority. A collaboration monitor detect coordination risk. A rack component retrieve relevant project knowledge and historical context. The student receive actionable recommendation rather than simply viewing project data. Now consider an advisor. The advisor dashboard aggregate team health information across multi-project, monitoring agent identity warning signals such as missed milestone or declining communication activity. The system then generate intervention recommendation based on historical project outcome and retrieval knowledge. This proactive behavior is the central innovation of CollabAgent. Instead of reporting problems after they occur, the system help prevent them. The architecture follow a layer design at the bottom. The data layer store structure project information alongside vectorized semantic knowledge. The application layer manage business logic, API, and workflow service. Above that sit the AI orchestration layer. Multiple specialized agents collaborate to monitor activity, prioritize tasks, retrieve knowledge, and generate recommendation. This screen shows how users interact with platform. The dashboard centralize project visibility, task management, communication, and documentation. A key design goal was to reduce context switching rather than navigating multiple tools. User access project information through a single interface. This screen highlights the AI-specific capability. Several specialized agents operate within the system. A task recommendation agent identify priority, collaboration monitor, evaluate team health, and advisor assistant agent generate intervention suggestion. A knowledge agent retrieve relevant information through RAG. Together, this agent create a collaborative intelligent layer that support decision making. Beyond functionality, the platform was designed with scalability, security, and usability in mind. The database used normalized relational structure combined with vector structure storage. Security include role-based access control, JWT authentication, password hashing, and input validation. To evaluate the system, multiple sources of evidence were collected. Quantitative metrics include task completion time, workflow complexity, and update frequency, and retrieval latency. Qualitative evidence come from observation, and the triangulation approach increase confidence in finding. For the quantitative analyst focus on the operational efficiency. The primary question was whether intelligent orchestration could reduce coordination overhead and improve project workflow. Metrics capture productivity, automation, effectiveness, and information retrieval performance. For the qualitative finding revealed for recurring team, user reported improved user clarity, greater workflow transparency, increased trust in AI recommendation, and more proactive coordination. This slide represents the most significant outcome of the result and the finding. And here for the conclusion. In conclusion, CollabAgent demonstrates the potential of multi-agent AI as an active coordination layer for academic software development team. The platform unify communication, task management, and knowledge retrieval within a single environment. Let's move to the demo. So, and here I already create the theme, and I want to make here. So first, I need to make the document with register as phase 1 and the goal of the phase 1. And here it just queuing the document for the agent to record, and then I can make another one by compose that let the AI to generate all the tasks from the phase 1. So it will run the model to generate all the available tasks. Oh, it's not this one, so sorry. So can use another prompt to make another one. Let me try it again. So sorry. So make a specific one, and then in here it should run the model to generate all the tasks. Yeah, that is how the generate tasks have with the title and the detail about what task it's supposed to be, and can make it. Oh, yeah, and I can let it create all the tasks. In here, you can see that all the tasks has been created from the AI generated. And also in this one, I can make like team coordinator by reporting the action, the meeting, like today we agree on who will review or anything else, and just let it run the model.
Hi, I'm really sorry to interrupt, but we are past 3 minutes into our Q&A. So, are you close to completing your demo? Because we need it to keep at least 2 minutes for the Q&A.
Yeah, I think it should be okay, but the other one is just for the advisor role can just make the feedback, and also the analyze, just letting it generate the weekly report, and that's all.
Great. Thank you so much for your presentation. Do we have any questions? Professor Siva, do you have any question?
No. We have had long conversations with Seth, and I think he's shown substantial progress after a slow start. I think he's shown substantial progress, and I was like very happy with what he did. So I have no questions.
Thank
Great.
you.
Thank you.
Nice job, Seth.
Yeah, thank you.